So, let's talk, and then we're going to get into some new stuff. Let's talk about a few things. I felt your grades from last semester, everyone passed. So congratulations to you all in class. I want to challenge you all to this. I just want to put the challenge out there just as a goal, a personal goal for you. So first semester sometimes gets goofy. It was goofy because we, ended it before break. We started it earlier. It wasn't technically as long as it had been. And so there's all these teachers that are all goofed up, and I'm like, whatever. But my challenge is this. I would challenge you to improve your grades by 5% of what you had last semester. 5%. Well, I think we can do this. I think this is a good goal. If everyone does it, you have to buy everyone donuts. All right, so everyone gets 5% better. Mac buys everyone jelly donuts. Just because I like jelly best. And don't worry, I'll make it happen. Being that Mac's buying donuts. So I don't think this is a horrible goal to shoot for. I mean, I think some of you could do better than that. I think some of you had in the first couple weeks of school dug a little bit of a hole for yourself, and then were trying to get out of that hole for the rest of the semester, in which, most of you did. There was a time where there was a handful of people who didn't have the best grade in here, meaning they weren't passing. But everyone brought their grade up to a passing, so that's congratulations to all of you. So I think if you got a 5% improvement from last semester, from last semester's grade to this semester's grade, I think that's a pretty cool goal. Now, unfortunately, everyone's grade is undefined because you have 0 out of 0 points right now, and you're like, no, I thought I had an A. 0 divided by 0 is undefined. That's when you do it on the calculator, it says error. So everyone has a U, and they're like, dude, I have a U? Sorry. So I think that's a lot to go. Now, how could 5% happen? I think 5% could happen by, how the game is played. So if you had a silly habit of not necessarily trying your homework as hard as you should have last semester, maybe you should just put a little bit more effort into it. I'm going to just mark you off, I'm spot checking it. I mean, if you have nothing but, cartoons drawn all over your paper, obviously you didn't do your homework. So it's 4, 3, 2, or 1, or 0 if you didn't do it for the homework stuff. But a couple of things to think about. Is it okay to ask questions during class? Absolutely. A lot of times, and this makes you normal because I know that I did it and I'm kind of normal, or I'm abnormal. They told me she's abnormal, which is still normal to a sense. I was the kid that would be like, boy, I hope there's a trail of ants walking through the classroom so I can watch them. Or I hope a grasshopper hops across the floor. Or I hope something happens outside so I can watch it. And all of a sudden, the bell rings. You're like, oh. I sat here for 50 minutes and got nothing. So what kind of things will help you pay attention? Well, you guys all know that if you have to use the restroom, please, by all means, use the restroom. You don't have to ask. I just don't want a flock of you going all at once because I don't think these restrooms could accommodate 22 of you or 24 of you, how many there are. So if you need to use the restroom, you know your digestive system best. So don't feel that you have to ask. Just go to the restroom. So that's first thing. If life happens some night don't keep me in the dark on it. If Aunt Ruth came into town, took you dinner, and then you went bowling, and then you decided to go see the midnight movie and you couldn't get your homework done. Life happens. I don't know if you have an Aunt Ruth or not, but I'm just using it as an example. So that's about it. I think all of you can catch on from there. So let's figure this out. So at the end of the semester, we were doing this where we were graphing two straight lines with each other. Do you agree? And those two straight lines could do three different things. They can cross each other, giving you one solution. And the solution was a point, x comma y. Yes? They could be parallel to each other, in which they would not cross, and that would result in zero solutions, right? And then the weird one was they could be the same line. Let's just pretend I can draw that really well. Hey! Hello. Thank you very little. Oh, yeah, he's not here. No, who's our kid here?
I have no idea. Sorry.
He's not here today. Thank you. So they could be the exact same line and lie right on top of the other. And so this could give us that sideways crazy 8, which is called infinite. That could give us infinite solutions. Does that all kind of jar your memory a smidge? And I know that most of you is like, no, which makes you normal. So in order to draw two lines, you have to have two equations. I want to focus on all three of these scenarios, but this is the first one I want to focus on. Does a point have to be two nice numbers? No. You could be a big old fraction, you could be a big old nasty decimal. Mean number? Mean numbers. Okay? So, these could be some big old fractions, big old decimals. They could happen way, way off what your XY axis was drawn, and way, way off what my X and Y axis would be drawn. Okay, there could be situations that take place that kind of make this a silly scenario. This scenario and this scenario are pretty obvious when graphing. There's certain indicators to realize that you have parallel lines, meaning the two slopes would be the same, and that would mean that we have solved both the equations for y, and you realize that y equals mx plus b. The m value attached to the x is our slope. If the slopes are the same, then you're going to have parallel lines. If you solve them both for y and they become the same exact equation, then duh, they're the same equation, same line. So those are just a few things that we're dealing with. But I want to talk about this, and if it's a weird, silly solution, meaning some weird decimal, some weird fraction, or a fraction comma a decimal, or way off your grid, graphing isn't always the best way to solve a problem. Is that okay? Can I say that? So, today I want to talk about something called the substitution method. Okay, we're going to do the substitution method, and then we're going to do something called the elimination method. So by the end of this unit, you will have last semester have talked about graphing. This semester started with substitution, and then we would have talked about elimination as well when we get done with the unit and by the end of next week. Substitution is a pretty good way to solve a problem. Okay, so let's say I had, let's say we had 3x plus 2y equals 6. And then let's say I had y equals 8. So this one, if I had graphed this one, I could probably use the cover method and say, well, x is 2, and y is 3. And that's what this looks like. What does this line look like? Straight. Yeah? So horizontal line, great. So this is a horizontal line, which if I had drawn this, would look just like that, for the most part. So that has a slope of 0, it's a horizontal line. If I were to put these two graphs together, there could be some sort of intersection that does indeed take place with these two lines, and this right here would give me my solution. Okay? But if I were to use the substitution method, I have this and I have this. What's a value I definitely know as far as my answer will be as an ordered pair? Any ideas? My ordered pairs, I have an x value, I have a y value. Still with me? Do I know a y value right now? What is it? 8. So this answer is going to have a y component of 8 for right now. Now I've set it up as a little more simpler situation, but if I were to say, well, I know my y value is 8, so what is that going to become? Y 16. Yeah, there you go. So if I were to take this, I have 3x plus 2 equals 6. There had been a y right here, but I'm going to plug the 8 in that I know, so I can go ahead and solve this. Is that okay so far? Help me out. This looks like a couple-step equation. Garvey, how do I solve that? I like it. I'll subtract 16 from both sides. So that's that gone. Tristan, how do I solve that? There you go. Divide negative 10 by 3. I like it. And then that gives me negative 10 thirds. Or I could turn that into negative 3 1/3. Or I could leave it like this. I would actually prefer you, for the most part, to leave it. Oh, I don't know why I got an 8 there. Must have fallen off and bumped my head a little too hard. So I get negative 10 thirds comma 8. I think you might agree with me that it might be tough to graph on the xy axis and find negative 10 thirds exactly on a graph. 8 is easy. But the negative 10 thirds, which is negative 3 1/3, might be hard to estimate on a graph. But if I use the substitution method, I plug one into the other to solve, I can get an answer pretty easily. Now, I'm going to show you some that probably aren't going to come up with nice answers. I'm going to do that for a reason. If they come up with a nice answer, I got lucky, I'm guessing. So let's try another one real quick. Now, I'm going to make it a little bit tougher. So this one, I knew that one of my equations was a horizontal line. I had one of my values automatically known. I just plugged it back into the other. But let's make another one where I have two equations that aren't one of them just being a number. So let's say I have 5x minus 2y equals 1. And let's have y equals 6x minus 7. Okay? Two different straight lines. Agree? Will they cross? I think so. How do I know? Well, it doesn't appear that they'd be parallel lines because I know the slope of the second one is 6. And if I were to go and solve the other one for y, I'm pretty sure the value next to the x isn't going to be a 6 because I have to subtract 5x from both sides and then divide by negative 2. And that's not going to give me 6. So do I know what one of my letters is equal to? I know what y is equal to. But it doesn't give me y equals a number. It gives me y equals, like, stuff. So y is indeed equal to this. So what I'm going to do is I'm going to use substitution. So taking what I know for my y, I'm going to substitute it in to my other equation. And by me doing this, it's going to take me having 2 letters down to 1 letter. So I know that this equation is 5x minus 2. This had been a y, but I'm going to plug in 6x minus 7 now. Do you see how I went from 2 different letters to 2 same letters now? I went from x and y to x and x. And if I have x and x, I can combine x and x together. So let's do the math. Summers, what am I going to do with that negative 2? Okay, so distribute was what I was looking for. So Reese helped you out a little bit. I like it, so I got this. So let's see, that's negative 12x plus 14 is equal to 1. So remember, I distributed the negative to both. Now I can combine my 2 like terms. I can combine 5x minus 12x. TJ, what do you get?
Negative 7.
Negative 7x. Okay. It's kind of a simple thing. Gage, what do you think I should do to solve for x on that? You're close. Step before that, though. Subtract what? Yeah, I'm going to subtract 14 from both sides. I like it. That's canceling that, so I give me negative 7x equals negative 13. And then you'd help me on that. You jumped 1 step ahead. What should I do? Last step? Divide each side by negative 7. And it would have been nice if that stayed as 14, but it's 13. Oh, my goodness. So I now know that my x is equal to negative over negative, which is positive. 13 over 7 will not reduce. Now I have a sneeze that's coming. Woo! Okay, so my answer is going to be an ordered pair. So I have an x and a y value. Do I know one of the values now? I know that x is 13 over 7. What do we know y is? 6x minus 7. So technically, this could go here. I could put 6x minus 7 right down there. But what value of that do I know right now? What value do I know of 6x minus 7? I know x. I just found it. So I'm going to take this, and we're going to draw some arrows. Plug that right there. So I'm going to take 13 over 7, plug it in for x. So I get... Ooh, this is a nasty problem. 6 times 13. 6 times that's 18. Carry the 1. That's 78 over 7. I'm going to make that 7 over 1. Oh, didn't I teach you guys this way? 78 minus 49 over 7. 78 minus that. Let's see. 78 minus 49. Oh my goodness. It's not accepted to be improper though. It's more acceptable to keep it. Now I will tell you that I will take an improper fraction for an answer, but it's not acceptable as far as math goes, because 1 and 6 over 7 sometimes becomes looked at like 16 over 7. Okay, so improper fractions was a neat thing that they showed you to make sense of what a fraction was, but it's more accepted in the math community to keep it as an improper fraction just because things start looking bad. So, yes, this answer is totally acceptable. That's 7, that's 4 and 1/7. No? Yes? Okay. So this is I'll take this answer. this is more of an accepted answer to have it as an improper fraction because this starts becoming, with writing it over and over and over again, 16 over 7 because of bad penmanship. And this becomes 41 over 7 because of bad penmanship. And 16 over 7 is not 13 over 7. And 41 over 7 is not 29 over 7. And what I'm saying is, I'm literally saying that improper fractions mixed numbers a lot of times get confused becoming back into a mixed number, or a mixed number going into an improper fraction. So be very cautious when you are rewriting it like this. My feeling is keep it like this. I know through the math communities and the science communities, the improper fraction is the more acceptable approach to it. But that aside, if I had graphed these two problems, aside from the really, really precise student in this class, would it be kind of hard to see that my line crossed at 13 over 7 and 29 over 7? Yeah, I think so. So that's why substitution is sometimes going to be a better method. Graphing is a good method because it gives you a picture to look at, gives you an idea of the representation. But if you remember when we said, hey, it looks like it crosses here, and when we plugged it back in, it might not have come out right. It might not have come out right because we might have drawn our graph without rulers, and we might have been off a smidge. So, can you guys try a substitution problem for me? Can I write one up? Can I get rid of this? Okay. Try that. Give it a try. Jot down on a... Check yourselves real quick. I'm going to just start it. So I want an answer as x comma y. Still with me? So I'm going to take this. Where does this go?
Where y is.
On the other equation, correct? Okay, try that. That was your first step, though. Try that, though. Yeah, we did. So, if you went from here to here, do you agree? Does your word correlate with what I'm doing? Does that look okay? C? Okay, good. Combine like terms so you get this. Is that right? And then this. And then, what happened here? That's an uglier fraction, yes? But x is equal to that. Okay? So that's the first step. Now, here is a question. Here's a question. I know what the x value is equal to. I have how many equations given originally? 2. I can plug that x value into either of those. Now, one of them is probably a little better to plug that x value into than the other. Do you agree? If I plugged it into the 3x plus 4y equals 1, that's a little more math. It's going to give you the same answer, but it's a little bit more math. So it's your choice where you want to plug it in. So being I know that this is an x value right here, I can plug it into this x value or to this x value. One of them, again, is going to be a little bit easier than the other. They'll both yield you the exact same answer. So does the y equals 2x minus 3 appear to be easier to plug x into than the other equation? What do you think? What value am I looking for? What value am I looking for now? Y. Does the first equation already have y isolated?
Yes.
It does. So I'm looking now for this y value, or this y value. It's going to be the same no matter where I plug it in, but I'm looking for a y value. So if I take that 13/11ths and plug it in right there, I'm going to get y equals 2 times, there was an x there, what am I plugging in? 13/11ths. Now, yes, it's going to be ugly, it's a fraction, I get it. And I told you I was going to come up with ugly answers. Is that okay so far? So then I'm going to combine 26/11 minus 3/1. And again, if you use my fancy way of adding and subtracting fractions, 26 minus 33/11. 26 minus 33 is going to be a negative answer. Negative what? Negative 7 over. Ooh, that's a store.
Negative 7.
Or it's 7-Eleven, isn't it? So I think you all would be okay to say with, if I were to have graphed these, you probably would not have been able to figure out that the x component where graphed was 13/11ths where the two lines crossed, and negative 7/11 where the other one crossed. Okay? So these are crossing lines. The ones I had done just before were crossing lines. When they're crossing lines, they have one solution. That one solution is the ordered pair of x comma y. Still with me in this adventure? So the two examples I had done were two lines that if I were to have graphed them, they would have intersected each other, giving one solution. And that one solution is given as a point. That point is x comma y, just rephrasing what I just said. Is that okay? But you remember, back in the graphing days, there was a chance that they could be parallel to each other, which meant there was no solution. Agree? Yeah.
For the, isn't it supposed to be 26 or 22? Because 2 times 11 is 22.
Where are we at?
It's the second, like.
Right here?
Yeah. Why isn't it 26 or 22?
No, remember, it'll be over 1, so I go top to top, bottom to bottom, 1, and multiply fractions. That's an easy one to sometimes get goofed up. Do you see that? Is that okay?
Yeah.
Okay, so let me try a problem that it's going to give us a strange answer. So I'm going to do y equals 3/5x minus 6. And then I'm going to do 5y minus 3x equals negative 30. So if we use substitution right now, I could plug this right here. Where? Next to the 5, because it's a y, right? Watch what's going to happen. Okay, watch what's going to happen. What was here originally? A y. What's going to go there now? 3/5x minus 6. Okay? Now I'm going to distribute over the parentheses, so distribute here and here. So Mac, remember, top to top, that's going to give me 15/5, right?
Yeah.
X minus 30 minus 3x equals negative 30. Does that look okay so far? Is there a fraction up there I can reduce to get a whole number? What's that? 15/5 is the same thing as what? 3/1, which is the same thing as? 3. So I get 3x from there. Do you agree? And then minus 30 comes along for the ride. Minus 3x equals negative 30. Still with me? If I combine my like terms right now, what letter's gone? X. So I get 3x minus 3x, they're gone. So I get negative 30 is equal to negative 30. I no longer have an x. Is negative 30 equal to negative 30? Is that true, George? Negative 30 is indeed equal to negative 30. You like that? Seem okay? This means that if I were to have graphed these two lines, they would have been parallel to each other. Or wait a minute, they would have been the same line. They're lying on top of each other. If they lie on top of each other, how many solutions we have?
None.
Infinite. If they're parallel, we have none. If they lie on top of each other, we have infinite. So wait a minute. This is a true statement. That's true. One number equals to exactly itself is definitely a true statement. That means these would have been the same line. Same line means it has infinite solutions. So for every xy on one line has the same xy on the other line. Okay, so we have infinite solutions. So this is true. Any guess what would happen if we had parallel lines? I will tell you that the letters are all going to fall out, but what's going to happen rather than a true statement? It's going to be false. You're going to get something ridiculous. You're going to get like 5 equals 12. And it's not because you discovered this new, math theory. You go, dude, sweet. Everywhere there's a 5, I'm putting a 12 in now. Sweet. So if you were to, infinite solutions, you get a guaranteed true statement. If I had something that I worked out the whole problem, this is all their work, this is work, and we come down and we get 7 is equal to 8. If that happened, if you've gone and plugged it in and your x's or your y's fall out and you wind up with nonsense, so one number equal to something different than itself, this is no solution. This would have meant that the lines would have been parallel to each other. And Reese, we know parallel lines never do what? They never intersect. And if they never intersect, you don't have a solution. If they don't have a solution, no solution would work. Huh. We cool? I can't talk now. So what? So
Sure you can.
all right. All right. So your first assignment is going to be worksheet number 2A, which is page 124, 125. It looks like it is 13 questions. 13. So, if you didn't bring your stuff or you lost your book, I have a couple of extras. If you'd like one, it's good for a few days. Anyone need extra? Right? Anybody else need one?
Yes, please.
So this will be good for a few days. This will take us up.
Yeah, I just left my backpack.